So again, in this equation, we're trying to find a unit and we're trying to find the units of KE. And I give you a little bit of information, but again, I've given that information worded in a slightly different way than actually outright telling you the units. We're going to have to apply a little bit of logic along the way as to what our units are going to be. So the first thing I'm going to do is I'm going to rearrange this equation for KE. So KE is equal to, if I multiply both sides by r squared, I end up with FR squared, and then I divide both sides by Q1, Q2. That is now rearranged for KE. Now, what I tell you in this is I tell you what each of the terms is describing. So my units of KE are given by my units of F, and I tell you that F is a force of attraction between the two charges. So this is why we need to kind of look back over our units that I've given you above and just telling you which unit describes which thing. And when it's a force, it's a Newton. R, I tell you, is a separation. A separation is a distance. And so here I have a distance squared, so meters squared. And then I actually tell you here that the charge in coulombs of the particles here. So I have a coulomb here and I have a coulomb here. Now, I could theoretically leave the unit at this, but I promise you it should tidy up a little bit if I start to replace some of these derived SI units by their fundamental SI units. And so here a Newton is a kilogram meter per second squared. Meters squared are already fundamental, and a coulomb times a coulomb, well, that's a coulomb squared, and a coulomb is an amp second squared. So amp second all squared here at the bottom. And so I can just tidy this lot up again. If I have my kilogram meter s to the minus 2 meter squared over amp squared second squared, this will give me, if I combine these together, I have a kilogram meter cubed, because a meter times a meter squared is a meter cubed, and then I have s to the minus 2 on the top and s squared on the bottom. Don't be tempted to cancel these don't cancel, these end up as s to the minus 4. And then I have amps to the minus 2. So that is the answer that is in fundamental SI units. As I said, I could have also just left it with the derived units. This is, as far as I'm concerned, a slightly less correct unit, which would be a Newton meter squared per coulomb squared. So allowable, but not quite so correct. I hope that this helps. So quite often, I suppose the lesson here is that quite often when we're given values, we're not told exactly the unit, but because we're given a description of it, we should hopefully be able to work out what units we need to apply to the different situations.